So this chapter 3A is about triangles, lines, and angle properties. We'll be reviewing a lot of ideas behind triangles and lines to set you up for this chapter. So you'll learn about triangles, their properties, the properties of angles on lines, and also finding angles, the interior and exterior angles around these triangles and the lines. But before we start, I have to warn you that you must learn all the math vocabulary in this chapter. It's a very vocabulary heavy chapter, so you cannot pass this chapter without learning this actual math language. So take extra notes about the vocabulary, ask extra questions, but you must know the vocabulary. So in this first skill, we need to review the types of triangles that we have in mathematics. So the first one is an equilateral triangle. In an equilateral triangle, all the angles are equal, all the sides are equal. That's why it's called an equilateral triangle. The second type of triangle is an isosceles triangle. In an isosceles triangle, only two sides are equal and only two angles are equal. The third type of triangle is a right triangle because of the right angle that's in the corner. And we always know it's a right angle because it's always indicated by the symbol of a little square in the corner. Automatically, when you see this little square in the corner, you should know that this is a right triangle. And the last type of triangle you need to know is a scalene triangle. A scalene triangle has all different side lengths and all different angles. Nothing is the same. So in summary, these are the four types of triangles that you need to know in order to solve the problems. So again, to review, equilateral triangle, everything is the same, all the side lengths are the same, all the angles are the same. At isosceles, only two angles and two side lengths are the same. A right triangle is significant for the right angle, and a scalene, nothing is the same. No angles, no side lengths. So given that knowledge, you need to, in this exercise, calculate the third angle in each triangle and state the type of triangle in each case. And just as a quick reminder, it doesn't really matter what type of triangle it is, but all triangles, no matter what, every single angle is always, always, always equal to 180 degrees. So for example, if I had this corner was 10 degrees, this corner was 30 degrees, these two add up to 40 degrees, meaning that this final corner has to be 140 degrees. Now clearly this example is not drawn to scale. It is completely inaccurate to the numbers I've written, but the numbers are just an example to help you understand that all three angles in a triangle must add up to 180. So now stop the video, solve for the missing angle, and tell me what type of triangle they are. Pause. So in the first case, this triangle is 45, 90, 45 because this adds up to 180 degrees. This type of triangle, because it has two side angles that are the same, it is considered a isosceles triangle. But also, because it has a 90-degree angle, what makes it special is that it's an isosceles right triangle. In the second problem, B, 30 plus 60 plus 90 will make 180 degrees. all the angles are different, so this makes it a scalene. But also because it has a 90-degree angle, it's special. It is also a right triangle. So this triangle is scalene and right. Not all triangles will have two special qualities to it, but these first two happen to. The next triangle, 25 plus 45 makes 70, plus 110 makes 180. All angles are different, therefore it is scalene. And this last one, 60 plus 60 is 120, plus another 60 makes 180. All three are the same, therefore this is an equilateral triangle. In this skill, we're going to review the properties of angles on lines. So, first of all, we need to know what parallel lines are. Parallel lines run side by side. They're just like train tracks. So technically, parallel lines can be running up and down. Parallel lines can also run sideways. Parallel lines can turn diagonally. So parallel lines, they always run next to each other and they never intersect. And when I say they never intersect, it means they never cross. Perpendicular lines are lines that run and cross each other. They intersect and they always create a 90-degree angle. No matter what, perpendicular lines intersect to create a 90-degree angle, no matter what. Now, a full rotation, if a line were to travel all the way around, it's a full rotation, which means it is automatically 360 degrees. So if you had lines crossing and intersecting and you wanted to know what the whole range added up to, it's automatically 360 degrees. The next part is just knowing what a straight line adds up to. A straight line, no matter what, always adds up to 180 degrees. So if I had a line here, this angle right here plus this angle right here will add up to 180 degrees. If I were to draw another line right there, this part, and this part would still add up to 180 degrees. Now it gets a little bit tricky. So now we're going to start talking about angles and what happens when lines intersect. So vertically opposite angles are when two lines cross and that the angle right across from it, so imagine that they make that X shape, the angle right across from it is the same value. So for example, if we know that this part right here is 30 degrees, the one opposite of it will also be 30 degrees. This part right here is vertically opposite of this part. So if this is 150 degrees, so will the opposite. And just for your information, if you look at the straight line here, this part of the straight line is 30 degrees. This part of the straight line is 150 degrees. Together, it adds up to 180 degrees. The next term we need to learn are corresponding angles. You know corresponding angles are equal, and to find the corresponding angles, think about the letter F. So the under part of the letter F these two pieces are equal. So if this was 110 degrees, so would this one. Now sometimes we can think about an F being backwards as well, so we could look the other way. And so the under part of this angle is the same as this. So if this was 70 degrees, so would this one. Now, this part right here above the 70 is corresponding to this part, because if you think about an F upside down, well, there you go. So therefore, this is 110 degrees. And if that is the case, so is this one. And just so you see a little more of a relationship, this part right here, the 110 in red, is actually vertically opposite of the 110 right here in the black. Therefore, they have to be the same. And here's just another extra bit of information. If this is a straight line, this portion right here, from here to here, that's 70 degrees of the 180. Therefore, the rest of it is 110, and together they add up to 180. The last term we need to learn are alternate angles. Alternate angles are a little bit tricky. You have to think about the letter Z and finding the angles that are fitting within the Z. And Z can also be backwards. Sometimes it can actually go this way, and you look at the parts opposite of it to find where the alternate angles are. And those parts, the alternate angles, are equal. But another thing to think about is you also have this part of the Z, which is the same as this part of the Z. So you also have to think outside of it. But of course, if you can't figure that part out, it's okay to use the ideas of corresponding angles and vertically opposite angles to find what the value of those angles are. Now, using what you've learned about angles, find out the values of D, E, and F. Pause. Okay, so here we go. Now, of course, I don't have to just find D, E, and F. I can actually find everything else that's not labeled. So I'm going to go ahead and do that to solve my problem. I know that this 50 right here is vertically opposite of this one. Therefore, this is 50 degrees. I know that this 50 degrees is corresponding to this part because it is an upside down F. So F has to be 50 degrees. I know that this is a straight line. So if this part is 50 degrees and a straight line adds it to 180, this has to be 130. And that being said, I know that this part is 180 degrees because it's a straight line. So if this part of the line is 50, therefore the rest of it has to be 130. And also, just from looking at it, if this was a backwards Z or an S, this part right here, the 130, is actually alternate angles with D. So D and E are alternate. And so here's the one thing I'm just going to say about solving problems like this. There's really no real one right way. There's so many different ways you can do this, and it really doesn't matter how you do it. It's basically how you approach it. And as long as you approach it in a way that makes sense to you, then you're fine. And finally, the last skill is applying all this knowledge you learned about triangles and angles and lines to situations where you start to combine triangles and the lines. So for example, when we look at the first problem right here, now just to let you know, an interior angle, interior means the angle inside the triangle, if there's or a shape. An exterior angle is the angle outside of the shape. There is no continuing shape, it's the outside of it. So if we look at this first overall shape, we can first see, well, it's an equilateral triangle because all the angles are equal. And then we can start to solve it in many different ways. In this case, I have no parallel lines that I'm working with. I know that I'm working with 180 degrees, straight lines, and so forth. So go ahead at this time, pause the video to work out these two problems. Do the best you can. Pause. So given that this is a straight line right here, I know that 60 plus something has to add up to 180 degrees total. So therefore A must be 120 degrees. Now, given that this angle is the same as this one and this one, that means all of these exterior angles need to be 120 degrees. Now this problem's a little bit tricky. And again, my way of approaching it could be completely different from yours. This is what I'm going to do. I know that this is a triangle. I want to find that missing angle. So I'm going to solve for it. And I remember that a triangle always adds up to 180 degrees. So I'm going to use that to my advantage. First, I'm going to take 48 and 58 away from 180. 48 plus 58 add up to 160. 180 minus 106 will be equal to 74. So I know that this angle right here, C, is 74 degrees. Okay, so that's the first thing I found. Now I have to find A, D, and B. And well, I think I'm going to work with B first because it's easier, being that if I were to continue this line right here, and also, do you see these symbols right here? They indicate that these two lines are parallel. So if I were to just extend this line a little bit more, then I will see it a little more clearly. I can see that this one, angle B, and 48, well, they create that Z shape I talked about. They are alternate angles. Because they are alternate angles, B has to be 48 degrees. Now finally, I think I can go for A because I see a straight line here. And I have one part of it, I have the second part of it, now I just need the third part. So here's what I'm going to do. I'm going to take 180 degrees and I'm going to subtract whatever 48 plus 74 add up to, because 48 is B and 74 is C. 48 plus 74 add up to 122. So 180 minus 122 will be 58. So A is 58 degrees. And just from looking at it, 58 and A are actually alternate angles. Now, from here, some of you might be saying that, oh, 74 and D, oh, they are alternate angles. They actually aren't, and the reason is this, because this part right here is broken away from that parallel line. So you can't say that D is 74. So here's another thing you can do. Here's 180 degrees. 58 plus what makes 180 degrees? So in that case, the angle should be 122 degrees. So A is 58 degrees, B is 48 degrees, C is 74 degrees, and D is 122 degrees. So with problems like this, you have to work with the problem. It's going to get a little bit messy, but you have to work around the whole problem. You don't go in order, you just work with it and work with what you can see in whatever order you want and solve the problem. And that's it.